Okay, so I've been known to, when I give paper pencil tests, I do terminology, little vocabulary tests for you. So I prompt you with questions like these. The first question being, a function f of x is increasing when? Well, how do we know a function is increasing? We know it's happening when the derivative is positive, okay? A function is decreasing when the derivative of that function is negative. Remember, increasing derivative positive, decreasing is the derivative is negative. Likewise, if f prime of x is positive, then can we conclude? We conclude the original function is increasing. And if we know that the derivative is negative, then we conclude the original function is decreasing. Okay? So it says, recall the values of x where the derivative is equal to 0 or f prime of x is undefined. Those are called those critical numbers or the critical values, the CVs, right? So what are we going to do to determine intervals of increasing and decreasing? What we are going to do is the sign chart method. You have to remember the sign chart method. Okay, the sign chart method is what we used in the intermediate algebra and college algebra review when we were doing inequalities. We wanted to know when a function was greater than 0, which means positive, and we wanted to know when a function was less than 0, which is negative. So what were the steps for the sign chart method? Well, the first point was to find where it's equal to 0, but in this case, we're going to find where the derivative is equal to 0 or undefined. In other words, we need to find those critical values. So the first thing that you do is find those critical values. The second thing that you're going to do is create a number line and then plot those points and determine the intervals. The third thing you do is you take one of those points in each of those intervals and you plug it into the derivative. If the derivative at that point is positive, then that entire interval is positive. If the derivative at that point is negative, then that entire interval, the derivative is negative. And then you make your solutions. You interpret your solutions. Where they wanted it increasing is where the derivative is positive, and where they want it decreasing is where the derivative was negative. So that was a lot of talk. Sometimes it's easier to see it in action. So let's go ahead and do it in action for example 1 here. It says, find the open intervals for which f of x equals x cubed minus 3/2 x squared is increasing or decreasing. Okay, so let's do this. Step 1, what you want to do is you want to find the CVs. Okay, so let's find those critical values. F prime of x, well, the derivative of x cubed is 3x squared. The derivative of minus 3/2 x squared would be minus 3/2 times 2x, so that would be a minus 3x. We're going to set that equal to 0. It's never undefined. And it's important, again, that you always remember you have to set it equal to 0 or undefined, especially when you have rational functions or radicals, etc. So we have 3x squared minus 3x equals 0. Let's go ahead and solve that by factoring out a 3x. 3x squared divided by 3x would just leave an x, and minus 3x divided by 3x would leave a minus 1. We set that equal to 0. We set each term equal to 0. 3x equal to 0 gives me x equals 0. And x minus 1 equal to 0 gives me x equals 1. So these 2 points are in the domain of my original function. I can plug them in and get a y value for the original function. So these are called my critical values. They're where the derivatives equal to 0 or undefined, and they're in the domain of the original function. Step 2 is the number line. We need to make the number line and determine the intervals. So let's go ahead and do that. Here's a number line, It's an infinite number line, and then we just plot the points. Here's the point 0, and here's the point 1. These are my x values, right? Up here, I want my function values. At 0, we know the derivative, not the function value, the derivative values. And it's important you plug them into the derivative. We know at both of these points, the derivative is 0. We have to consider our intervals, negative infinity to 0, 0 to 1, and 1 to infinity. And the idea is we go on to step 3 now, and we test points in f prime of x. So instead of checking an infinite number of points, we only need to check one point in each one of those intervals. When I care about this is the actual sign chart. We don't care about the derivative value. We just care about whether the derivative is positive or negative. So if you remember, let me set this up for us. We have the x values, and again, we're plugging them into the derivative. The most easy way to do this is to plug it into the factored form of the derivative. So I'm going to plug it into 3x times x minus 1. You'll see why in just a second. And then I need a point in each one of those intervals. So let's pick a point between negative infinity and 0. How about any point works? I'm going to choose the x value of negative 1. We need to pick a point between 0 and 1. I'll pick an x value of 1/2. Again, any value between 0 and 1 would work. And then I need to look in that last interval, any number between 1 and infinity, any number bigger than 1. I don't know, heck, I'll pick the number 10. It truly doesn't matter which number you pick. Pick easy numbers that are easy to plug in. Now, when you plug them in, you do not care about the number. You only care about the sign. Is it positive or negative? Okay? So think about 3 times negative 1 would be a negative number. And then negative 1 minus 1 would also be a negative number. So we would have a negative times a negative, which is a positive. So think about 1/2. 3 times 1/2 would be a positive number. 1/2 minus 1 would be a negative number. And any positive times a negative is negative. Let's think about 10. 3 times 10 would be positive. 10 minus 1 would be positive. And a positive times a positive is positive. So what do we have? We can go back to our sign chart and we can put these values in. Because negative 1 was positive, that entire interval, the derivative must be positive. Because 1/2 was negative, that entire interval, the derivative must be negative. And because 10 was positive, that entire interval, the derivative must be positive. So that's us completing the sign chart. Now we need to do step 4, which is to interpret what the heck we just figured out. Well, what do we know? We know if the derivative is positive, that function must be increasing. If the derivative is negative, that function must be decreasing. Again, the derivative is positive, so it must be increasing on that interval. So let's look at this. What were the intervals of increasing? The intervals of increasing were from negative infinity to 0 and 1 to infinity. Negative infinity to 0 and 1 to infinity. Notice we're always going to use parentheses here. Where was this decreasing? It was decreasing where the derivative was negative, which was on the interval 0 to 1. So we were able to determine the intervals of increasing and decreasing not by looking at the graph of the function or the original function, but rather looking at the derivative of the function. Where was the derivative positive? Where was the derivative negative? We were able to interpret that as where's the function increasing and where is the function decreasing.